command. So here's ASM 100, where we're going to start with assembly code. You have to install a few libraries to make 32-bit code, and then you can make it. So if I do ls-l, I've got hello.asm here. ASM is typically what you put in your assembly code. All right, so here's the assembly code. It defines, I have a text section. The text section is the section that has code. And I define the start here as a global variable. That's where the code is going to start. And here it does executing a few commands. And then here's a data section. And the data section stores this string, hello world. And then it has a length value, which is going to be the current location minus the start of message. So that's going to be the length of this string, the current location. And so now I put length in EDX, the message in ECX, the pointer to the string, then EBX1 and EAX4. 1 is the device number to write to, 1 is standard output terminal, and 4 is the syscall. And this int 80 is a syscall. Now this is how all programs work in every operating system. The operating system is written by somebody like Microsoft or the people that wrote Linux, and it's the only part of the code in the machine that runs with high privileges and can access the hardware. Accessing the hardware is a restricted activity that only things in ring 0 can do with high privileges. All the code you write and everything you see on your desktop and everything you launch with the start button runs in userland. It runs in a low privilege environment where you cannot send any signals directly to the hardware. All you can do is ask the operating system kernel to do that for you. And int 80 is the syscall. And these are the parameters that go in. So all you can do is call the system routines in the operating system to do things for you. You can't add any new ones to it, not unless you write kernel modules and load them in, or device drivers. So you get used to this pattern. All you do is load some parameters and do a syscall. Load more parameters and do a syscall, and that's all your program is doing. Syscall, open a window. Syscall, draw something on the window. Syscall, read the keyboard, that kind of stuff. Everything you do is just calling the operating system. So here, what we're doing is 2 syscalls. Int 80 is the system calls, and there are a lot of syscalls, but EAX is what determines which syscall you're calling, and you see 4 is write, and 3 is read. So here, I loaded 4, so this is a write, and it will do, and if you look at the details of the write syscall, it tells you here, it will write to the file descriptor, the size of the buffer, and the count. That describes the prototype. And so you have, those are what goes in these parameters, and the parameters are always in a certain order, A, B, C, D. So this is the syscall number, this is the file descriptor, 1 is standard out, this is the address of the string to print, and this is the length of the string to print. That's what you do. So all of this here will print hello world. And this is exit. Yeah, syscall number 1 is exit, so this will exit. That's what's going on here. This is the print hello world. This is the exit. That's what it looks like in assembly code. So now we can run it this way, and you can compile it. Here's how you compile it. There's 2 steps to compile it. You use NASM to assemble it in ELF32 format, which is executable link format. That is Linux 32-bit code. So that creates hello.asm, and if you do ls-l, see what's in here. I'm going to remove hello and remove hello.o. So I started with nothing but this. Now if I do the NASM is going to assemble it, and what that's going to do is create the object file, which contains the assembly code, but it now has to be linked to system libraries. And you do that with the LD command. This will link it to the 32-bit system libraries, taking the object code of hello, combining it with libraries to create the real executable hello. And now if you look at what the result is, you'll see hello.asm is only 212 bytes. The object code is only 600 bytes. It's only a little bigger, but the finished product is 8 kilobytes. That includes the links to the library. And that's the one you can run, /hello. And so it prints hello world. Now notice it doesn't even print a new line. It just has the next line start shifted over here. And that's because if you look at my code, let's just nano the code. Minus W none to get rid of the colors. Hello.asm. All right. Nano. What? Oh, it's minus y none, pardon me. That's W is something else. There we go. All right, so here's the code. And see down here, I defined hello world, but I never put in a carriage return line feed. If I want to do that, I have to put them in here. Now, those are not printable characters, so you put in 10 and 13. 10 is the ASCII code for line feed and 13 for carriage return, or else it's the other way. But I added those in. This will automatically make the thing 2 bytes longer. So if I put in that code, and now I recompile it, first with NASM, and then I link it with LD, now it should have the carriage return in it. And it does. Now there's a carriage return to go to the new line. So that's a simple example of how you print things out. And just knowing that much, you can now read theory on assembly language program and answer questions about theory, which is good for you to do. This is not hands-on coding. This is just reading this tutorial and understanding some basic concepts. And then if you want to do the hands-on, I was writing this down here. And what I did was, since all you know is how to print things out, you can now print things, but if you print a properly formatted GET request, you can get it to my server. So this is what you have to print out, several lines with carriage return line feeds and an extra carriage return line feed at the end. This is a properly formatted head request. This is what you do to get a response from a web server. Head, the name of the host, and then a blank line. So when you do it right, you'll get a response which will contain the flag. And then you can make a GET. Here, this is what the GET looks like. Now if you go to this page and log in with admin password, you'll see you can do that, admin, password. And when you log in, you get in, but you don't get the flag. In order to get the flag, you have to log in with a different user agent. Now, a user agent is automatically sent by your browser, and it identifies which version of which browser you're using. But in order to get the flag, you have to log in with a user agent of ASM code, which is not a valid browser. So you're going to have to write your own script that will create just this string. This is the GET that does this. This is a HTTP GET going to that page and passing in the administrator name and password. And this is the name of the URL that it goes to. And you have to put in this user agent and then a blank line. So it's a small step forward from the previous one, which did a head request. This will do actually a login request. And when you do it right, you'll get a flag. And there's another one here where now you can use a loop and you can log in. So you're going to open this web page and you're going to log in with GET. It's admin and the password is password followed by a single digit. So once again, you could do it manually here, but you won't get the flag. You could do admin and then password 0 and log in. And anyway, you can try all the different passwords here, but you'll never get the flag because you have to have a different user agent as well. So again, you could write 10 requests, or you could just make a loop that counts up to 10. Both of those are good ways to do it. And here's another one where you have admin has a digit and password has a digit, so it's going to take 100 guesses to get in. So those are some good things to give you some practice writing simple assembly code. Got a question? Yeah, what's up?
Yeah, I need help.
All right. Well, let me stop this video then.